A limit is the value a function or the dependent variable approaches as x, or the independent variable goes to a certain specified value. So this value can be more abstract, like infinity, which we see a lot in calculus. I drew the function in pink and the point in blue. The x value is 4 and the corresponding y value is 6. A basic limit question will ask you, what is the limit as x approaches a certain number? In this situation, I chose that number to be 4. To answer this question, we must break down the problem into two parts, the left limit and the right limit. The right limit is the y value the function goes to as x approaches the point from the right side. The left limit is the y value the function goes to as x approaches the point from the left side. Let's start off with a right limit. So the arrow represents the direction of the limit. The notation for this is the letters LIM, which is short for limit. Below that we have the independent variable followed by an arrow pointing to the number x approaches, which is given in the problem, which is 4. Since we're working on the right limit, this is followed by a little plus sign. On the right side, we can see visually that the function approaches 6, which is the y value of the coordinate. The left limit has a very similar notation to the right limit, only instead of a plus sign, it has a negative sign in the same spot. The function approaches 6 from the left side as well. Because both limits are equal to 6, the limits are essentially equal to each other. This isn't always the case, but when it is the case, you can use this notation, which does not have a plus sign or a minus sign. You cannot use this notation unless the limits are equal to each other. Let's do two practice problems together now. The first problem is asking us to find the limit of f of x as x approaches 3. As x approaches 3 from the right side, we can see that the function values are approaching 5. And on the left side, the function values are also approaching 5. Thus, the limit of f of x as x approaches 3 is 5. The next problem asks us to find the limit of g of t as t approaches negative 4. As t approaches negative 4 from the left side, the function values move towards negative 2, and on the right side, the function values also move towards negative 2. So the limit as t approaches negative 4 is negative 2. But what if the left-hand and right-hand limits are not the same? Well, it's really no big deal. All we have to do is remember that the notation used must specify which side limit it actually is. Let's see this in action. In the graph below, we can see that the function is split by a jump discontinuity at x equals to 2. I will be making a more in-depth video about discontinuities next, so stay alert for that. Since the function is split at x equals to 2 because of the jump discontinuity, if we want to find the limit of the function as x approaches 2, we must divide it into two limits, the right limit and the left limit. Let's start off with the right limit. As x approaches 2 from the right side, the function value approaches 6, which is the value of f of 2. On the left side, the function value approaches an open circle, which is a hole and a type of discontinuity. Holes are not a value of the function. So that means that f of 2 isn't equal to 4, it's equal to 6, because that's where the closed circle is. But even though this point is not a value of the function, it doesn't really matter, because limits are what the function approaches. Approaches is the key word here. So the limit of the function as x approaches 2 from the left side is 4. Thank you so much for watching. I hope this video helped. If you have any questions, please leave them in the comments section.